Okay, and we're live again. Welcome everybody to the Azure and AI Show. We have some new speakers with us again this week. So we have Precious. She's going to do a session there on root table in Azure. Also, this week we have Parig, and he is doing a session on revolutionizing banking operations with human AI synergy in intelligence document processing. Very interesting. Also, we have Savannah, his session on autonomous incident remediation with generative AI for cloud reliability. Some great topics there coming, and we had another speaker that was supposed to join us, but we'll announce that as we go along. So, Precious, I'll leave you go first there, and then we'll have Sarah Vannan and Padraig then after that. Okay, you can see your screen there. Do you want to share your slides? Yeah. We can see that there now, yeah. You're on mute there now, Precious. Precious, you're on mute.
Yep.
Okay.
Yeah.
Okay, I guess you can hear me now.
Yeah.
Yes.
Hello, everyone. Welcome to AI and Azure Show. We are back again this Saturday, and I am happy to be on your faces today again. So the last time I was here, I talked about network security group and how they filter traffic in the Azure or in the Azure network. Now, today I'm going to talk about route table. I'm sorry, you may get some background noise that's coming from my kids. I hope you understand that. So today I'm going to talk about, my name is Precious, by the way, and I'm talking about Azure route table today, that in a very simplified way for beginners and people who are yet to know about route table. Now, on my slide, I have navigating the complexities of cloud networking can be a challenge. This presentation will make Azure route table simple to understand as one of the essential tools for managing network traffic within your Azure environment. We'll explore their fundamental roles, practical applications, and advanced configurations to help you build robust and secure cloud infrastructure. So now, what is Azure route table? Azure route table acts as the central navigation system for your network traffic. Much like a detailed roadmap, it dictates how data packet travels between subnets, virtual networks, and even external destinations like the internet or your on-premises data center. When we talk of Azure route table, you have the traffic director. What traffic director does is it defines explicit paths, ensures data always goes where it's intended. Also, we have security enforcer. This controls the traffic flow. They help enforce security policies, directing sensitive data through firewalls. And the last but not the least, I have hybrid connectivity. They are crucial for seamless communication between your Azure resources and on-premises infrastructure. In my next slide, I have real-world scenario or situations of Azure route table. So here, to better understand the concept, let's look at a simple example from our everyday lives. Imagine your data packets as cars traveling on a vast network of roads. Azure route table has a sophisticated traffic sign guiding these cars to their correct destination. Now, the cars on this analogy is more like the data packets. Then the roads I specified here is the network part. Then the traffic signal is the route table. Now, each piece, coming back to the data packet, each piece of the information flowing through your network is like a car with a specific destination. Then the road, which I identify as the network part, the underlying network infrastructure provide the pathway for your data to travel. Now, the traffic signal, which is the route table, the route table acts as the intelligence signal, telling each packet precisely where to go next. Now, why Azure route tables are important? Route tables are more than just networking features. They are critical components for maintaining control, security, and efficiency in your cloud environment. Without them, network traffic would be unpredictable, leading to potential security vulnerabilities and operational downtime. One of the things it does, one of the importance of route table is it prevents lost traffic. Route tables ensures data packets always finds their way, avoiding dropped connections and latency. Also, it enhances security, allows you to force traffic through network virtual appliances like firewalls for inspection. It also gives granular control. Route table provides precise management over network flows, optimizing performance and resource utilization. Also, diving deeper in the concepts of route table, how Azure route table functions. Azure handles network routing in two main ways: system routes and UDR. System routes, which are automatically generated, and custom routes, which you define to override or enhance the default behavior. Understanding this component is key to mastering traffic flow. Now, what are the components? You have the destination. The destination is the IP range that has route applied to it. You also have the next hub, which specifies where the traffic, where to send the traffic, matching the destination. Also, the subnet association. A route table must be associated with one or more subnets to be effective. Now, the two main features of route table, which I mentioned earlier, is the default route and the custom route, which is also known as user-defined route. When we talk about custom default routes, Azure automatically creates system routes for common scenarios, such as traffic within a virtual network to internet or through virtual private network gateway. This ensures basic connectivity without manual configuration. Then when we talk about the UDR, I mean the custom routes, you can create custom routes to override system routes, allowing for specialized routing needs, such as passing traffic through a firewall or a network virtual appliances, which I stated as the NVA, which is that's a short form of network virtual appliances. Now, when the packet travels, this is what happens. When a data packet needs to leave its current subnet, it doesn't just randomly search for a path. Instead, it carefully consults the route table associated with its subnet. This process ensures an ordered and predictable journey. It checks the destination against all routes, prioritizes the most specific match, and then directs the packets to specific next hub. Now, the foundations of network control, Azure route table being the foundation of network control. Azure route table are integral to, a minute, please. Chimotuko, please, you and Tim should stop this. Chimoto, you and Tim should stop this. I'm sorry, I didn't even go mute. All right, I'm going to go back to my slide.
Okay.
So now, Azure route table being the foundation of network control, is designed for secure and high-performing and resilient cloud network. By mastering their use, you gain unparalleled control over your data journey, enabling advanced security posture and seamless hybrid operations. This comprehensive view shows how this comprehensive explanation I've given so far, although it's on the basic level, shows how the signal route table can direct traffic to various destinations based on your configured next hop role, demonstrating its power in complex network environments. Integrating route table with Azure firewall and network security groups creates a layered defense, while their role in hybrid connectivity ensures your cloud and on-premises resources communicate effectively. So now, right now, I'm going to quickly go over to my demo. Right here on my demo, I have already did some configuration. To start with, I have set up my virtual network with the subnet I need. And also, I set up a virtual network and 3 subnets, including 1 subnet for Azure version for connecting to my virtual machines, 1 subnet for a public subnet. The next subnet is a private subnet. Then the other subnet is a DMZ subnet for our MVA. When I say DMZ, I mean a demilitarized zone subnet, which is a subnet I use for the MVA, the network virtual appliances virtual machine. Also, I created a virtual machine, 3 virtual machines. These 3 virtual machines, one all in East US, one is deployed to the private subnet. The next one is deployed to the public subnet. Then this other one is also deployed to the DMZ subnet, which is my MVA. Now, what I'm going to do right now, I have also configured the route rules. I have created my route table because I didn't want to take too much time. And I can actually take a lot of time to do this. Although if I try, I can actually do it. But so I created the route table. I configured the rules. This is the rule here. So here, what I did here, I configured this rule to private subnets. This route table, the name, I configured it to be a public route table. Then I configured the rule to public subnet. I used the destination type. I applied IP address. You can also see there is service start, but I'm using the IP address. Now, this is the destination IP, which is this represents the private subnet where my private VM lives. This is my Nest Hub. There are other Nest Hub type you can find here. You have the internet, you have the virtual network, you have the virtual network gateway for your on-premises connectivity. This is none. That means it can go to anywhere. So I'm using the virtual network appliance. This is the IP address of my NVA. This right here is the IP address of my NVA. Now, after this connectivity, after this setting up this rule, I came back here to associate the public subnet to this route table for efficient connectivity. Then there is also one thing I did. I came to my MVA. In my MVA, I enabled IP forwarding in the NIC, which is very important. So this is already enabled. So I'm not going to I'm not going to touch anything around there. So I'm going to go ahead to confirm my connectivity. To confirm my connectivity, I have to log into my public virtual network through public virtual machine through my MVA, through my version. I'm going to start this. This is my public key. I'm going to connect. Just going to give it some time. It's going to come up. but maybe I can try connecting from here if that's giving network issues. And that's the more reason I had to set up everything, because I didn't want to go through the network. Okay, here. This server is already up. So this server is already up. I'm going to track the path. I'm going to track the public VM path. Temporary failure. I just want to make sure this server connects. But let me try here again. It's giving me failure. Okay, the VM is turned off. We're just going to wait for this VM to come up a bit, just in a minute, in few minutes. It's up now. I'm going to try it again. Okay, now you can see it picked it. The reason it was giving the temporal failure was because the VM I was trying to track was turned off. Now this is it. And if I go over to that VM and do the same thing, I'm still going to communicate with, connect to this private virtual machine. So that's it for route table for today. And thank you very much, everyone, for having me.
That's great. Precious, it worked out in the end. Patience. Anybody, any questions for Precious on the road table?
No, this is fantastic, Precious. Thank you for presenting, and also a demo, cool demo. Thank you.
Yeah, no, definitely. That's really good.
You're
Thank
welcome.
you.
You're welcome.
Okay. So are you okay there to go ahead there, so
Yep.
Saravana?
Yep. I'm gonna start sharing. And thanks, Parag, for the flexibility. Appreciate it.
No problem at all.
Can you all see my screen?
Yeah, we can see your screen there now. Yeah.
Okay, give me 1 second. I'm gonna
Very good.
let me start sharing. Yeah, yeah. So today, my topic for this conference is autonomous incident remediation using Gen AI for improved cloud reliability. Just for context, I used to be at Microsoft for the last 12 years. I used to own their Microsoft's incident automation platform, which used both rule-based as well as AI-based engine for autonomous incident remediation. So that's my topic for the day. And I currently work as a product management leader for Axon Enterprise. So let me start with the problem. So if you look at the industry today, if software engineer needs to, if there's a live site issue, an outage or a problem, you even if it's the middle of the night, like 2 a.m., an engineer has to wake up and understand what's going on with the live site issue, and they may have to go through several thousand logs, different diagnostic systems, and this is just there is a lot of human manual labor that's involved, and that causes the overall mean time to recovery, that's MTTR, to be higher, but also causing the operator fatigue. Or over time, that's kind of like one area in the software engineering that's very painful. I would rather focus on building and architecting versus having to maintain constantly this manual complex architecture that only grows over time with overwhelming number of this cloud microservices that need to talk to each other, and the complexity only grows over time. So there are a lot of telemetry signals that needs to be parsed through, and there is overwhelming data landscape that's there that human operators cannot fully track. So that's the problem statement. Now, if you look at the limitation of our traditional incident response, you have four issues here, four buckets of problems. First one is manual diagnostics. The correlation of various dependent systems and fragmented tools and diagnostic tools that are split across various organizations within any large enterprise, it just causes degradation and constant incidents and outage for customers. So if you think about Microsoft scale, we're operating at planetary scale, from healthcare to law enforcement to Department of Defense to whatnot, everything. And any outages impact and exacerbate over a period of time. And like the recent outages caused issues with the flight delays and what have you. And the second problem is related to reactive escalation. So after the fact, after an outage has happened, we are then trying to engage the right engineer, and there's predefined escalation path, yes, but that each click stop causes delay. And then the third problem is around fragmented context. There is not a single diagnostic platform or a solution. Uh, the engineer has to go and take a look at fragmented diagnostic tools, and there is also tribal knowledge. Over a period of time, a team or grows, the tribal knowledge grows, and the pattern recognition only happens in certain engineer, not for all of them. So the on-call rotation kind of doesn't really work for like engineers who just recently joined the team. And finally, there's all of this causes like operator fatigue, and there is a repetitive task that's going on in this reliability and the incident management space. So that absolutely impacts the physical well-being as well as mental well-being for this engineer. So that's why we're introducing autonomous incident remediation. This is a closed loop framework for enterprise cloud, and this is a tested system at Microsoft scale. And the intention is to use the latest, greatest Gen AI platforms for automated incident remediation. So, which also means that this system should be capable of making a production code or a config change while maintaining a human oversight when and where as necessary. And the system also need to be explainable. The AI has to be explainable so that we bring full transparency and we are able to build trust not only within engineering community but also with the customers on the other side. So if you look at the framework, there are 5 major or core components to it. The first one is the Gen AI engine itself, which is the LLM that's used to identify the root cause. And the second part of it is the governed automation. This is all about the autonomous execution boundaries. And I mean, we need to define what is a boundary for this Gen AI system. It can't go rogue, and there absolutely needs to be policy-driven risk classification, so that the AI model operates within a boundary. And then you have safety checks and monitoring, especially if you're touching a production code change. And then over a period of time, we need to understand what was the root cause and what was the remediation, what actions was taken, and are they all compliant? And so we enforce the audit and compliance. And the output of all of this, let's say over a period of time, there are hundreds of outages that were remediated by AI systems. That becomes the input for future learning. So there is continuous feedback loop for learning and refinement over a period of time. And then if you look at the first component, the GenAI for contextual diagnostics, you have data ingestion. Absolutely, the GenAI system needs to understand the various telemetry signals that and the monitoring signals that you may have defined based on your own metrics and your own systems. And the context synthesis is, this is where you need some prompt engineering to understand if you see this type of problem historically, look at these millions of incidents. This is how we dealt with it. And if you see slightly different problems, and this could be a gradient of problems, you could act in XYZ different way. That's the context synthesis. And we also need to provide this type of prompts to generate the hypothesis for the root cause by the AI driven system. That's the first step of it. The second one is this AI model needs to be aware of the risk aware, and there needs to be a certain extent of policy governance built into it. That ensures that the models don't go rogue, and also conservative controls placed during peak hours during business. And if you need to roll back, or mitigate a problem using a production code change. So all of that, we need a policy governance system built on top of it. And I'll talk about what specific Azure specific AI systems we used, but that's the second component. The third one is about the layered safety validation pipeline. Firstly, we need to have the pre-execution check. So even before I make a production code change for a given outage, we need to validate and make sure that what potential failure patterns have we observed, and what is a blast radius, and do we need to engage a human in loop for a given blast radius? If it's like Sev0 outage is super huge, and it impacts various different multiple different regions, cloud regions, then we can define certain rules to engage a human in loop in that scenario. But if it is a repetitive scenario, or if it's a smaller blast radius, then the system can potentially self-heal. So that type of a layered self execution check needs to be there as a first step. Second one would be real-time health monitoring. This is where the health of the system and the metrics, the error rates, the perf, all of that needs to be monitored real time, and that goes as an input into the AI model at the time of availability drop or any outage scenario. A third one would be automated rollback, and this is where I talked about if the AI system understands that there is a health degradation, rather than letting the cascading failure happen. So if there is an issue with the cloud net, then the compute goes down. Then there is the cloud net is the networking layer. If cloud net fails, then you don't have the connectivity to the compute, and the storage goes down. That is, all of the systems that are built on top of it goes down as well. The Teams, the Office 365 cloud, what have you, SharePoint, ODSP, everything goes down. So rather than preventing this degradation or cascading failure, we need to have the automated rollback built into it, so that we address the or we mitigate the cascading failures. And then the fourth step would be the post-action validation. So let's say you make a code change. How stable did the system become after the code change? How quickly did we recover? So all those multi-layered approach helps with the safety of this autonomous recovery. And then you have the third one, which is a third pillar for the framework, is the transparency through comprehensive audit trails. And for every decision, we need the traceability and the transparency through explainable AI. So why did AI do the step it took? So that is where AI is typically it's considered a black box, but we need the GenAI system to explain what are the steps it took, and that each step, each click stop becomes an audit trail for later, if later during a post-incident review or postmortems or retrospective, whatever you call, that becomes an input to even further refine the AI models. Um, and then the fourth core component here is a continuous learning, or actually this is the final one, the continuous learning and refinement. Um, so the framework goes through a loop. So the first one would be the incident detection. So we need to define certain anomalies and trigger the autonomous incident response workflow. So once that's triggered, we at Microsoft we used Azure Logic Apps as the underlying layer for defining the triggers and the actions. And then on top of it, we also had the GenAI model. So that will be the GenAI specific diagnostic, which is the second part of the flywheel, where it looks at the contextual insights, including the prior outages or the related diagnostic logs, and generates contextual hypothesis. And the third one, the third part of the flywheel would be the governed remediation. So this is where I talked about the policy controlled, safety and checks validated, production code or config change, and finally it would be the outcome analysis. Let's say if human was involved, this might have taken like 90 minutes for resolution, versus the completely remediated like autonomous remediation, it took less than say 10 minutes. So, and where do we have the opportunity for further improvement? And did it diagnose the root cause effectively, or were there some issues with the root cause validation? So all that becomes a model's input for further refinement over a period of time. So it continuously learns and becomes better. Obviously, if you look at this type of a model, it has definite advantages over a traditional rule-based automation. So if you simply look at if then else, like a rule-based automation, it requires explicit rules for every specific scenario. If you have a VM that's like constantly rebooting, that type of issue, then you need to define a solution for that specific problem. But the problems could be thousands, and then every time an outage happened, it could be completely different from what you have a predefined existing list of those scenarios. So this is where the generative AI learns the patterns over a period of time using historical data, and it can recommend the right solutions, and it can generate the hypothesis and come up with the right root cause, even if it is not part of the predefined list. The second problem with the traditional route-based automation is, especially when you encounter novel failure, it's hard, and it just fails at that point. You really need a human to be engaged at that point. And then the maintenance burden grows with complexity. As I was talked about, like multiple dependence services, it is just becomes exponentially hard to maintain and manage. And given the modern architectures and complex microservice architecture, it's just uh, very difficult for an engineer to who's on call to manage and help with the lifestyle situation. And so here is a Azure aligned implementation architecture. So you absolutely need the Azure monitor and the app insights. That is the input into the system. That provides a unified telemetry for any of the metrics, logs, and the traces that your Azure architecture may have. The second step would be the OpenAI service itself, and it could be semantic kernel, but you need an enterprise grade LLM that constantly looks at these signals and looks at the retrieval augmented RAG as well, so for contextual diagnostics. And the RAG model may consume the inputs not only from the monitoring system, but also from historical incidents as well, and outages as well. And the third part of the architecture is the governance policy itself. So native policy enforcement and compliance controls are absolutely important. And the fourth one would be the Azure automation and the logic apps. And this helps with the orchestration, the overall orchestration end to end, and with validation capabilities. So that is how Microsoft has done at a planetary scale for outages and incident management. And here is an implementation roadmap that any enterprise could also make use of. The first phase is the foundation. We really need detailed telemetry baseline, integrated monitoring systems. It could be Azure Monitor, it could be your own different monitoring system, but absolutely we need a really good monitoring system for observability signals, and we need to build a historical incident repository as well. So over a period of time, all of this becomes a knowledge base for the Gen AI model. And then the next step would be the AI integration. This is where the OpenAI service, the Azure OpenAI service helps with RAG, and also with helps with the improved diagnostic accuracy. And the governance layer that we talked about for audit and compliance frameworks is critical. And then we can start with a pilot. Maybe you can pick a certain services, start low risk, uh, and then you can graduate onto higher frequency or higher severity type incidents and outages. And this type of a framework would help land with lowest possible risk and highest success rate. And yeah, this ultimately for any organization, this reduces the mean time to resolution. So this helps improve the customer satisfaction for all of the Azure services that you have in place, and your net satisfaction score will also expect it to improve. And to wrap up, I want to share that the faster recovery and durable cloud reliability becomes a key for success for any of the cloud systems that you operate at any scale, be it planetary scale or like even at a smaller scale. Uh, the faster incident resolution directly translates to uh, the consumption revenue recognition, and also with the improved customer satisfaction over a period of time. And I think that's it for today. But let me know if you have any questions.
Great presentation. Very interesting. Um, don't have any questions coming in on our chat, but any of you guys have any questions?
No, that was really good. I mean, it's really good use case as well. I think fits almost everywhere. So really good.
Yeah, yeah, definitely. It's the way ahead, isn't it? Gen AI. Yeah, yeah. So I'm just going to hand it over to Parag. There, I
Mhm.
have your screen there up.
Okay.
Okay. Yep, we can see that there now.
I hope it's visible. Hey, hello everyone. I think you have already seen Azure and AI. So I'm also kind of, going to most of you, or rather all of you must have heard about AI by now, and as well as most of you might have used AI. So today, kind of, I'm presenting a different use case of use of AI and how it can help.
Yeah,
So this is topic is
no,
about
your screen.
revolutionizing bank.
Do you know
Sorry.
you're just having some internet problems there. Do you know sometimes if you just turn off your camera,
Hmm.
you'll get it better.
Yeah, let me try.
Yeah, try that there now.
Is it better?
Yeah, your sound is better now. Yeah.
Okay, sorry about that. Okay, so as I was saying, right, we already have listened to two amazing presentation around Azure and AI. So here I'm going to present another use case of the AI specifically for banking operations. So I'm being in banking industry for long, pretty long. So that's why this use case is around banking operation is because that's what I understand, and as well as I'm kind of working on cloud platform as well. So this particular topic is about revolutionizing banking operations with human AI synergy in intelligent document processing. So usually when you say document processing for banking, when you go to the bank, whether to open an account, taking a loans, you usually are required to, as a customer, you have to submit so many documents with respect to KYCs, different aspects of your slips, banking statement, and etc. And that's how it goes to the team of whoever is there in the bank. And today, basically, manually they have to kind of go through those from the KYC verification, whether it is loan origination, account onboarding, and look for all and make sure those are accurate, those are not fraudulent, and as well as it has all the required documents present before they can, process that request ahead. Right. And usually, if you see, it takes around 30 to 40% of operational budgets across the industry. And staff, you need a dedicated staff just doing that over and over again to go over all those documents, to make sure those are in at appropriate accuracy. But again, with the human nature, there is always a chance of having some errors. So usually, if you see, the error rates in this case will be around 2 to 5%, and that can have cascading impacts on compliance accuracy, customer satisfaction, etc. Strategic impact also is there is this inefficiency extends far beyond operational cost, right? It directly affects compliance accuracy, compromise fraud detection capabilities, or significantly diminishing customer experience in an increasingly competitive marketplace. Because if customer is not happy, they are very well going to go to some other bank or some other places. So accuracy and speed is the key to in today's world if you want to make the customer happy, as well as make sure your compliance and everything is in place. So this is, again, I just put it on high level, how much the manual processing cost is. As I said, 30 to 40% in operational cost budget. It's dedicated staff working 8 hours or sometime more, depending on the load that is coming in for those kind of requests, whether it's a loan. Like you might have seen during the COVID era, there was so many loans processing happening. So that kind of load also impacts the overall productivity. It can take 2 to 5, or in some cases, I have seen more business days, as depending on the load. And the one of the major critical thing is if there is an error while processing those documents, it can impact compliance, fraudulent, and everything else as well. So that's where the idea is of human AI synergy. So thanks to Microsoft, we already have certain AI tools like AI intelligent document, AI language at our disposal. So human AI model fundamentally shifts how banks approach document processing. So replacing human beings, it creates a sophisticated partnership where AI handles high volume, standardized tasks, freeing human reviewers to focus their efforts on complex and high risk cases. So this synergy combines the speed and consistency of machine with contextual understanding and ethical judgment. So divided into stages, right? One is the AI-driven document recognition, where intelligent classification and routing of incoming documents using computer vision and pattern recognition technologies. Second, embedded data extraction, sophisticated OCR, which is optical recognition, and NLP, natural language processing. These engines extract structured information from high is this is multi-dimensional scoring algorithm determining which cases are human reviews based on the is human in reviews focus on feedback, providing oversight, handling exceptions, continuously improving the AI model. I'll go all these in detail in the next slides.
We lost him. He's having some networking problems. I wonder, does he know he's after being kicked off? Will we give him a second to see, will he join? But Precious, I found that Azure is AZ104 on Microsoft Learn for you. I don't know, have you seen that? I'll just share my screen there. Oh, actually, wait a while.
Hey, sorry, I think I lost.
Yeah.
He's back.
You dropped there for a minute. Your
Let me go back to
internet.
the. Am I sharing the screen yet, or
No, no.
okay?
Share it
Let me
again.
share.
Yeah.
Okay, let me share. Share screen. Okay, let me know.
Yeah, we
Is it
can see the
visible?
screen
Okay.
there now. Yeah.
Yeah. Sorry about that. So yeah, I think. Let me explain the stage one again. So the stage one in this framework is AI-driven document recognition. So the foundation of intelligent document processing begins with sophisticated recognition capabilities. Advanced computer vision algorithms automatically classify incoming documents across multiple categories, including identity documents, financial statements, proof of address, other regulatory forms, etc. And this also can help to make sure all the required documents are in place for that particular application, whether it is account opening, whether it is loan processing. The systematic intelligence routes each document type to the appropriate processing workflow, eliminating manual sorting, dramatically reducing initial processing time. Pattern recognition technologies identify document variations and formats, even handling poor quality scans and photographs. This initial stage sets the tone for the entire workflow, ensuring accuracy and creating structured pathway for subsequent processing stages. Second one is critical, where it's basically automated data extraction. Right? So as the name suggests, once the documents are processed and available for further processing, OCR engines extract the relevant data feeds with a remarkable precision, and NLP algorithm understand the context, enabling the system to identify the key information even when formatting varies significantly, across documents. The extraction process handles both structured forms and unstructured documents. And this is something is really key because it can process all these data, make it available, and go through the accuracy and go through the all the reviews that it can do before it can involve the human at a later stage if need be. So real-time validation checks ensures extracted data meets format requirements and business rules, flagging anomalies immediately for efficient resolution. Third stage is the very much key on confidence-based decisioning. And as you know, AI, this is going to be a learning model as and when you start using this model more and more, it's going to learn more, and the confidence score will be more and more for most other documents. So the confidence is kind of divided into four categories. One is extraction confidence, where OCI quality scores and field level accuracy metrics. Document quality, where the image clarity, completeness, authenticity, uh, at that level. Risk assessment, fraud indicators, compliance red flags, and the last is the case complexity. Like that can be because of non-standard forms or some exceptional circumstances, which are not cannot be processed as is. So this multi-dimensional confidence scoring algorithm analyze each process document across these critical dimensions and automatically routing high confidence cases for straight through processing while flagging complex or high risk cases for human expertise. And that's where the fourth stage, human in loop review, comes in. So here, the task for the human or the is made easier because instead of going through all the documents that are coming in, here human reviewers receive a prioritized queue with the flagged cases requiring expert attention. The interface presents extracted data alongside original documents, highlighting the areas of concerns, providing relevant context. Reviewers can approve, reject, or even modify the AI decisions once they go through that particular highlighted section or even other relevant documents. And with their action feedings, that will kind of move that application for the further processing. But also, these actions that they are taking will also get fed for the AI learning so that this model becomes more and more relevant and more the accuracy increases as it goes further. So this human oversight ensures compliance with regulatory and requirements while maintaining the quality standards expected in banking operation. The system captures reviewers' decisions, creating an audit trail and enabling sophisticated analytics on exceptions pattern and improvement opportunities. So these are the very much core technologies enabling this framework. There can be more, but these are the bare minimum core technology that we can use to make this happen. One is, of course, OCR, optical character recognition. Most of you may know. As I mentioned, it kind of helps to classify the documents, handling multiple language, varied fonts, challenging image qualities. NLP, which is natural language processing. These algorithms understand the context, semantics, enabling accurate extraction from unstructured text and intelligent interpretation of those financial documents. Computer vision, sophisticated image analysis detects document authenticity, identifies tampering attempts, and various security features embedded in official documents. And real-time integration, which is seamless connectivity with core banking systems, regulatory databases, third-party, etc., to validate and make it as automated processing as possible. Of course, there are some best practices because this is whole model is kind of built for the banking. So of course, we'll be having PII data. We'll be having, especially the customer data. It has to have, to monitor the fraudulent data. So the security aspect is very much important here. So first is the document standardization. So depending on the loan processing, account opening, there are already regulations in place so that the document standardization can be easily acquired to see what kind of documents are required for uh, appropriate applications. Then multidimensional confidence scoring. This is key because if there's a high risk items, something is not clear, that can be easily go to human loop where easy straightforward processing can happen with automation, easing the human to only focus on the critical, possible fraudulent or the complex application processing. Last but not the least, secure scalable architecture. Design infrastructure with security at its core, ensuring data protection, regulatory compliance, encryption, build scalability into the architecture. As I said, like during the COVID, we have seen a lot of load coming in for the loan processing, home loan processing. So to make sure the scalability is the key, most of it with the cloud is today inbuilt. It just have to make sure you configure and it handles, but nonetheless, you have to make sure you are doing it so that it can handle the volume fluctuations and future growth without performance degradation. So measurable business impact, if you see, is faster processing, reduction in document turnaround time, cost savings, decrease in operational expenses, error reduction, because it's going to do the same processing every time accurate with the accuracy, and rather the accuracy is going to increase as AI learns more. But anywhere it is not accurate, not confident, it's going to make sure human is involved in loop to do the second eye validation and take the appropriate action and fraud detection. That enhance this enhancement in identification accuracy. So this is the overall model, and as we see, the AI is about continuous learning and model improvement. So all this process, as it goes through, the framework's effectiveness grows over time through systematic continuous learning mechanism. Even every human review decision provides training data, enabling the AI models to become progressively more accurate in their assessment. Regular model retraining incorporates new document types, evolving fraud patterns, changing regulatory requirements. Performance analytics identify specific areas for improvement, guiding focus enhancement efforts. So this is the continuous enhancement or improvement cycle. But the focus will be more on getting this AI model improve, and it is always and always going to give you more and more accurate results, reducing the overall cost time. So happy customer and everything as compliant as it can be. So it can, as I said about earlier, the security and customer experience. It will have the data security. It will have the
Yeah, your your network is kind of just giving you trouble there again, just at this point. Yeah, he's His network is failing again. I'll give him a second there to see will he come back again.
And just refresh.
Yeah. So just share that slide again with us. Sorry about that.
Yeah, I think I'm almost on the last slide. So hopefully.
That's security and compliance one there. 1 second now.
Yes.
Yep, that's slide. Yep, perfect. Everything else was perfect right up to this slide.
Yeah, okay, perfect. Good. That's really good. So yeah, so as I said, the compliance, security, and customer experience is as key as well as the benefits that we will get from this AI model. Regulatory compliance, as automated audit trails, consistent application for regulatory rules, comprehensive documentation ensure adherence to evolving compliance requirements while reducing the regulatory risk, and it will be always consistent every time. Data security, so enterprise grade encryption, access control, security processing environments protect sensitive customer information throughout the document lifecycle, meeting stringent banking security standards. And once you set this, it will be there for across all documents, so you don't have to worry about it. Last but not the least is the customer experience, which is because dramatically reduced processing times and improved accuracy translate directly into enhanced customer satisfaction, faster account opening, accelerated loan approvals. That meets customer expectations, and that's definitely is going to help increase the business for bank as well. So key takeaways, again, just a quick snapshot of what I just talked about is strategic partnership, not a replacement. So we are not here to replace human, because humans are still key when it is coming to the risk rating, fraudulent data, or high risk application processing. So here the AI model is more to help than replace. Second is the 4-stage framework, which is very much key. It's like a 4 pillars to make sure this is to make this successful. And last is to continuous improvement for this AI model, which will drive a long-term value. Because if you stop, it's going to be, it may not able to, it may not be compatible with the new regulatory rules or the new fraudulent detection that needs to be done. So continuous improvement is the key. And with that, I'm done with the model that I want to explain. Any questions? Anything?
There's no questions coming in on the chat. Anyway, great presentation. Very, how would I say, easy to follow.
Thank you.
And it was great to see, 30 to 40% out of the operation budget. There's one thing I was thinking, the fraud, do they have a special LLM that's kind of constantly being trained on the different types of fraud that are kind of popping up? Because,
yes,
that's
the key. Yeah, exactly. I mean, that is the key for continuous improvement, because as and when you learn these new frauds, new regulations comes in, you have to put in some efforts to train them. But it's like, once you train, it's there always.
Yeah. I see it there recently on an app that my health insurance company have. Before you take a picture, you upload it to the app, then you have to fill out all the stuff. What doctor did you go to see? What date?
Right.
How much is thing? Whatever. Now they're using the system like you just said there. You take the picture, the AI scans the picture, it fills out all the thing, and great customer experience then,
And agreed, exactly. I mean, I just presented from the banking perspective, but I believe this model can be used almost across all the industries where you need to process any kind of documents. So
yeah, very
definitely.
good.
Thank you.
So yeah, we're coming up on the hour. It was perfect timing. We did have one other speaker that was going to join us, but things happen. People can't make it sometimes, and so thank you everybody for joining us, and we'll be back here again next week. Precious, you will be back here with some other stuff on Azure again next week. you're here for the month of February doing stuff on Azure for us. And yeah, we're just up on the hour. So thanks everybody. We'll be back here again next week for the Azure and AI show. And we have another 3 new speakers lined up. And as I said, Precious will be doing stuff on Azure again for us. Thank you.
Thank you so much.